best to do it together. Okay? So we have to just fill in the blanks. Do you remember when we did this lesson, there were two applications. We had the smoke alarm and the carbon datum. Do you remember those two? Yeah? So let's try our best. Anybody who thinks they know the answer. Smoke detectors alert people to what? To run, to escape. They're not bad. Yeah. Although the verb is not right, okay? So alert. What your sentence would be: smoke detectors tell people to escape. Huh? Yeah, no, but you keep thinking the verb means to tell people to do something. Alert is a verb that means you're warning about something. So, like, I could alert you about danger. So what do you think the word might be? Smoke detectors alert people to fire. Yeah.
To fire?
Yeah. They warn people about fire. Right? Yes? Yes? Smoke from the fire is blank by the device, detected by the device, which then gives off an alarm. Good. One type of smoke detector uses blank 241. Yeah, that Americunium one, yeah. I don't know what the letter is for that. Yeah, whatever that thing is. A source of alpha blank. Yeah, radiation or particles. I think both will be fine. Both will be fine. To detect smoke. The diagram shows how it looks like. The alpha radiation blanks the air particles inside the smoke detector. Say again? No, go on, Ander. In? The alpha radiation in the air particles.
From?
No, we need a verb there if it helps, I think. Yeah, maybe a bit more academic than hit. Well, no, maybe hit's okay. Or collide, perhaps, or block. I wonder actually what they said. No, don't turn over. I don't want you looking. Oh, sorry. No. No, don't look. No. Yes, we could say hit or collide, but the word at the back, which is most academic, is ionize. Yeah, ionize. This allows a small electric blank to flow. Very good. If there is a fire, smoke particles going into the detector are blank by alpha radiation. Could it be ionized again? Let's have a look. I think it might be. No, we should. Now, de-academic word. This time they use hit. No. This reduces the ionization of the air particles, causing the current to drop. The drop in blank is detected. Yeah, the drop in current is detected by the smoke detector setting off the alarm. Smoke alarms contain metal plates and radioactive substance. The blank supply sends a voltage. Okay, so what provides a voltage? Huh? Yeah, what? The what? Yeah, so what? Come on, what's it called? It's small, it's a rectangle, it's in your phone. Battery, yeah. The battery supply... Oh, no, sorry. The verb is wrong. I thought it said the battery supplied, but it's the something supply. So you were right the first time, I'm sorry. The power supply. Sends voltage across metal, what? They actually said it earlier, metal plates. People are alerted when the alarm bell sounds. The alpha particles pass between the two charged metal plates, causing air particles to ionize. The ions are attracted to the blank charged metal plates.
Negative.
Does it have? Are ions always positive? Yeah. The ions are attracted to the blank charged metal plates?
Opposite charge.
Ah, very good, Andak. Maybe it's oppositely charged. Let's check. Ah, good man, yeah. The ions are attracted to the oppositely charged metal plates, causing a current to flow. Yeah. Okay. Carbon dating now. Carbon-14 is a radioactive... Could say substance. What else could you say? Not quite atom, another word. It's not quite... Isotope. Yeah. It is found in the blank in carbon dioxide molecules. What the heck could that be? It is found in... No, pecan. Oh, sorry, not pecan. Okay. It is found in the blank in carbon dioxide molecules. What could that be? That's a hard one. It is, it is found in the blank. I'm going to peek. Oh, that's terrible. Okay. No, I think we were all thinking like structure, orbital, outside, exterior. No, it is found in the air. Yeah. The amount of carbon-14 in the...
Air.
Yeah, now all of a sudden they've switched back to academic. So what's a more academic word than air?
Atmosphere.
Atmosphere, yeah. So the amount of carbon-14 in the atmosphere has stayed the same for thousands of years. There is a small amount of radioactive carbon-14 in all blank organisms. All living organisms, because it enters the blank chain, food chain. Yeah. Once an organism blanks, it stops taking in carbon-14. Dies. Yeah. Once an organism dies, it stops taking in carbon-14. The carbon-14 it contained at the time of death blank over a long period of time. Yeah. Go on, Siva. Yeah? Oh, I thought you got it, but you didn't. Not the right D word. Still not the right one. The smaller one. Oh my goodness, smaller, easier.
Disintegrate?
No, smaller. Decays. Decays over a long period of time, and the radioactivity of the material. So what happens to the radioactivity of the material? Yeah, no, we want a word that describes the process of it decaying. So the radioactivity of the material reduces. The approximate time since the organism died can be worked out by measuring the amount of blank left. Yeah, C14 left in the remains compared to the amount in living organisms. So, for example, I give you an example. I suppose I'm about 100 kilograms. Okay, if we find a caveman who's about 100 kilograms, if we measure how much carbon-14 is in him and compare it to how much is in me, we can work out how much has been decayed. Now you realise one problem with that is we're assuming when he died he had the same amount of carbon-14 in him that I do today. And maybe that's true. I mean, it's probably true because the atmosphere hasn't changed much. Okay, but at the moment the atmosphere is changing a lot because of human activity. So they consider that in the future people will not be able to date when you guys die, So I'm sorry to tell you this, but at some point you'll be dead, And in the future, somebody might find you and they might try to date you. You know, here is a physics student. What? Huh? Find you and date you, yes. And they could say, this physics student, they don't know how old it is, because it could be 500 years, it could be 1,000 years. The problem is our atmosphere is so contaminated, you can't date things that would have died after 1950. Because what has happened is there's lots of nuclear power plants, nuclear bombs, nuclear waste. You know, it's really contaminated. It's really contaminated everything. Okay? Yeah? My screensaver. Alright, let's go on to the next lesson now.